Okay, welcome back to the Q&A for day 2 of Handmade Hero. If you are in the Twitch chat or on IRC and would like to ask a question, please ask it now. And if you could, it would be very helpful. The only way that I'm going to be able to see them is going to basically be if you put C-Muratori, C-M-U-R-A-T-O-R-I, in your message so that I can see it. And that way I will actually be able to tell what is going on. Also, since we are starting to get more serious about the programming now, I would appreciate it if you would keep the questions to stuff that we actually did tonight or on a previous stream, so that we can actually focus on stuff like that, because otherwise we get bogged down in questions like what are we going to do later? And maybe we'll do some streams where we field questions like that, but I would rather focus mostly on questions about the code we just did, so that we can explain it more thoroughly and suss out any things that I went through quickly, because like I said, I always have to go quickly so that we can make some progress, and that means some things will go by too fast, and the Q&A is kind of where we can drill down into that. Okay, so let's take a look. Let's see. Expanding this out here. So we have, further along, let's see. Are atoms like intern strings? Yes, Dr. Jeets, they are like intern strings. Basically, I don't know if there's a good explanation of atoms on here somewhere that will say exactly what they are. I haven't touched them in a really long time, but it may be an atom, about atom tables. Here you go. An atom table is a system table that stores strings and corresponding identifiers. So, you know, that's probably as close as an intern string as you're going to get, right? Without actually calling it an intern string. So I would say yes, that's a fair way to describe them, certainly. They really aren't used that much in what we're going to do at all. Let's see. Can you go full screen with your cam for the Q&A? I would rather not, because I'd rather go and be able to show code like I just did there. So I'd rather not. I'm sorry about that. If I'm going to do something where I talk for a long time, I could try to do that, but I don't actually know how to do that without stopping the stream. I'm not sure how to do it in OBS. I got to assign some hotkeys or something. I don't know if it has that to switch profiles or something like that. Would be nice if while using the MSDN you could put the Chrome window on the right a little so we can see the code. Oh, okay. That's a good call. I'll try to remember to do that so that you can kind of see things. All right, yes, I will try to do that in the future. Thank you for that suggestion. Let's see. What's the fastest path for getting a pixel to the screen on Windows? Well, technically, we're going to show tomorrow the way that we need to do it. Which we will be doing. But if you really just want a pixel on the screen, it is actually set pixel, if I remember correctly. Set pixel basically allows you to set a pixel at a particular color and tell it what color you want it to be, and that is exactly what will happen. So if you want to actually do that, you can. It is this. I can actually do it for you if you want. We can basically say, okay, that device context that you gave us back at the coordinates 100, 100, I will set something to this color, and off we go, right? And if we then run the application, you probably, I don't even know if you can see it on the stream, but there is one little pixel there. I don't know if is zoom in installed on this guy. It is not installed on this guy. So yeah, you can see it, and as we repaint, you know, we can see that it still stays there, this little tiny pixel. So that is actually, if you literally just want the fastest way to set a pixel, that is the way. But we are going to be doing, it's way too slow. You'd never be able to render a game calling set pixel. Well, you could if it was a pixely game, I guess. But basically, we are going to show tomorrow the way to actually get pixels on the screen quickly. Well, and it's not even the quickest way. The quickest way is to use the GPU, obviously. But when you're rendering them yourselves, I'll show you one fairly efficient way to get them to the screen. Let's see. Let's see. Yes, so thank you for mentioning this. I think I should start doing this more. So things that take an actual string What I would like to start doing with those is actually start always suffixing them with ANSI or wide, which I described in the intro screen, but I should probably get to doing that a lot more. So if I go ahead and undef these variables here, let me go ahead and undef those variables just to see what's going on here. Register class identifier not found. Yes. So I will go ahead and make sure I call the ANSI versions of these guys. Just to be clear here, I don't think getMessage takes one, right? GetMessage is not something that takes a string, so it shouldn't, yeah. So basically the way that all these work, I mentioned a couple times, is basically all these functions can take Unicode strings or they can take ANSI, ASCII strings basically. And we want to always be calling the ASCII ones because if someone tries to compile our code using Unicode settings in the compiler, they will get an error because these are not specified as Unicode strings, they're specified as ANSI strings. So I am just going to go ahead and do that for the benefit of people who are trying to compile it at home, so when they download the source code, it will work. Let's take a look. Do you use the same technique for creating a full screen window? It depends on how you create the full screen window. We will be covering how to create a full screen window using a couple different methods, potentially, at least one method. And basically, you would use this method for the way that I think we will probably ship the game, but it depends. We will have to see. We'll have to do some compatibility testing and check it out. But I will be covering that later. Let's see. The for loop is just keeping the window alive, right? It's not related to the actual game loop. Well, we have not gotten a game loop yet, so we actually aren't in a position to talk about that too much. But basically what this is as soon as we exit, right, our app is done. So if I were to not actually do a loop here and not actually do an infinite loop, right, then once we actually start running, we will immediately exit, right, and the app will be over. Basically what will happen, if we step in the debugger, I step in here, I go through and I go create the window, and you can see the window. I don't know if you guys can see that flash, but it's there. There's our window, right? It got created. It just can't be brought to the front now because we are in the debugger, and once you're in the debugger, our app can't respond to messages, which means the window can't come forwards, and so on and so forth. But point being, we go right through here, we create the window, and then we return 0. So that's the end of our app. It will end up calling exit back in the C runtime library, exit process or whatever the function is in Windows that basically terminates the running module, and then we're gone, right? That's it. So in order to actually have our application run, doesn't matter if it's a game or anything else, we need to basically sit in an infinite loop processing messages until Windows actually tells us that we're done. Now, right now, we have no way of Windows actually telling us we're done. But if we wanted to, we actually could do that. We would go ahead and we would put that in here. We would put that in WM close, for example. We would do destroy window, and we would call the default actual stuff. Yeah, you know what? We're going to cover that. I'm not going to actually get into that because that's a whole other explanation because we're going to do that tomorrow when we make our window more well-behaved. Let's see. Can I pre-order the Epilepsy simulator? How much does it cost? Yes, you will get that tonight, in fact. If you pre-ordered and download the code from tonight, you will have your very own Epilepsy simulator if you download tonight's code and try to run it. I wouldn't necessarily recommend it if you have epilepsy, although I don't know if that actually would trigger epilepsy. Let's see. Wouldn't we want to make it so the user can't resize the window willy-nilly since the game will eventually have art with specific sizes? Perhaps, or perhaps we just want to try to adjust to the size that they want the window to be. And so we will be handling that stuff a little bit later. Right now, we might as well let them resize it, because why not? Before you start interfacing cross-platform development code, let's see, rendering. This stuff is all not questions related to the code from tonight, is it? Let's see. Can you experiment with what happens when you take out H-redraw and V-redraw? Yes, in fact, I don't think they're necessary at all. I don't think we care about them at all. I'm pretty sure we don't, in fact. And we can probably just take out OwnDC either. We're not even going to snap that copy of the OwnDC. Let's take a look here. That's awesome, right? Because it's toggling. It's toggling every time we get a repaint message. It's only repainting the part of the window that we don't, that got obscured when I bring it back on, right? Because the part that's below it now, when we come forwards, it needs to repaint it. And it's calling that repaint as I drag. So the faster I drag, the faster the more gets filled by each of the toggles of whiteness and blackness. So you can kind of do some fun stuff with that, right? Again, computers, they're crazy. They do what you tell them, right? Kind of funny. So yeah, HV draw, VRead, we don't need those. I don't know, those force of habit. I don't think we're going to need those. Let's get rid of them. Own DC, we don't need either. Let's just get rid of the style altogether and see what happens. Let's just get rid of the style. Yeah, it's gone. We don't care. It's fine. It's totally fine. So we're just going to leave it at that. Let's see. Any considerations for 64-bit on tonight's code you want to discuss? Not yet. I don't want to get into 64 versus 32-bit yet because hasn't really come up super much. Basically, the only difference between 32-bit and 64-bit compilation is 32-bit is basically a 4 gigabyte address space, and pointers are 32 bits because 2 to the 32nd is 4 billion, so that's how many bytes you can address with a 32-bit pointer, right? Where you're talking about individual bytes. 64-bit mode allows that address space to be 64 bits, which is way, way, way bigger. It's 4 billion times 4 billion long, obviously, because it's 64 bits. And so that is the only difference is all your pointers go from being 4 bytes long to being 8 bytes long, right? They go from being 32 bits to 64 bits. So basically, as long as you write your code so that you're aware of the fact that your pointers could be either size, which we will try to do as we go through our code. We'll try to be conscientious about that. But as long as you don't do anything that assumes it knows how big a pointer is, you should be able to be fine in both 32 and 64-bit. Now, there are some caveats there. If your code is trying to allocate giant hunks of memory, like let's say it's trying to allocate a gigabyte here, a gigabyte there, and big blocks and so on, it could quickly use up the 32-bit address space that it has under 32-bit Windows, which is only 2 gigabytes for application use usually, and so on. And that would be a problem for you. So there are some other concerns where 64-bit allows you to do a lot more. You can allocate huge chunks of memory and do all sorts of other things and memory map files in those spaces and all other sorts of things you can do in 64-bit without having to worry too much about clogging up the address space. But that is one thing additionally that you have to be aware of. But again, we are not going to hit any of that stuff. And so mostly we will be 64-bit and 32-bit clean all the time. And later on I will be showing you how to compile to both. So that you can ship on 32-bit Windows if you want to, even though that is now a relatively obscure platform. I think it's if you look at the Steam hardware survey, there's not much 32-bit Windows left. And in fact, why not just look at the Steam hardware survey now? So, OS version, we can take a look. 64-bit, 64-bit. I don't know, what is Windows 7? Is that Windows 7 non-64-bit? Let's assume that's Windows 7 non-64-bit. So 11%, that's 64-bit, a 4%, and a 0.07%. So I don't know, we're something like, that's something like 15% maybe on the Steam hardware survey. I don't know. I can't do mental math in my head. I'm awful at it, so I'm not sure. You'll notice all the Mac is 64-bit. All the Ubuntus look like they're 64-bit. So yeah, so basically, if you're shipping 64-bit, you pretty much got it covered. But if you want to get every last thing, you might want to ship a 32-bit version as well, I guess. I don't know. And who knows how accurate the Steam hardware survey is, but it's one piece of data you can look at to see how prevalent things are. Let's see. What about using locally scoped static const variables? Since they're const, there is no threading concerns, right? Well, that's true, but if it's const, why would it need to be static? That doesn't make much sense to me. A const is a constant value, so it wouldn't have to be static. It can just be replaced. And in fact, static and const conflict, don't they? Can you even declare a static const value? Yeah, I didn't think so. Oh, well, no, maybe you can. Let's see. No, I guess you can. I've never tried that before. Yeah, I'm sorry. I don't really know why you declare a static const value. Maybe there's some reason you would want to do that. But yeah, I mean, if it's const, then it doesn't really need to be static because you're not going to change it. And the whole point of static is to preserve the changes after it goes out of scope. So it doesn't seem to me like you would ever need to make something const static in that way. But it looked like it let you do it, so I mean, yeah, there's that. Can't say I don't see it. Let's see.
I'm compiling in VS, and for whatever reason, I'm getting a compile time error that tells me the initialization of the variables in the WM paint case are skipped. Yes, you will get that if you did not declare the block. So if I were to do this, so I don't declare the block properly, right? Now I will get that. Initialization is skipped, right? And what that's telling you is basically that you have declared variables in here, but you have not enclosed them in a block, right? So basically, if it was going to, when the switch statement comes in here, right? And in fact, I can tell you exactly what happens here, right? Let's say I come in here. If I were to jump in the switch statement into the default, right? So I come in here. Technically, because this is at the scope, the outside scope, it's at the switch statement scope, I could refer to paint in here, right? I could do something with paint, like paint RC paint left equals 5. I can compile that now, right? That's totally valid. You'll notice it did not complain about that at all. And that's bad because these variables, they just got hopped right over. So if they were to have an initialization, let's say I was trying to initialize that like this, you know, this would be thinking, oh, this will be initialized and I'll use it or something. I don't even know what would be going on here, but it wouldn't because it jumped over that code and into here. So I believe it's trying to just warn you of bad things that could happen along those lines. Hopefully that makes some sense. So device context, for example, is something that got initialized here, and I could go use it down here. Oh, I'll just paint to the device context, but psych, no, you can't because it was not actually initialized, right? So you want to make sure that you get, oops, I missed one there. You want to make sure that you put these little curly braces in the WM paint to make sure that these are enclosed in that basic block. There you go. So get message and dispatch message should also have an A suffix. Thank you for finding those. I'm not sure what all the things are that need those. So you're saying this one and this one are also Unicode and ANSI standard. Let's take a look, verify that. And I guess you're saying translate message isn't? Okay, good. So we've got all our A's in here, which is good to make it so that people can compile in Unicode without having to worry about that. Let's see. Let's see. You're nesting quite a lot of blocks there. Will you show how to get rid of too much nesting? I don't know why I would worry about nesting. Nesting is fine. There is no cost to nesting, really. It is not an expensive thing. It's free for the most part. The compiler can still optimize as much as it wants, really, where those things are placed and how they are cleaned up. I'm sorry, I guess I don't have anything to say about that. I don't think you should worry about nesting. You can nest things as deep as you would like to nest them. Let's see. My app doesn't respond to the window close button. Neither does ours. Neither does ours. Window close is not responded to yet. We're going to handle those tomorrow. So you have to basically, if you want to kill the window, basically you just kill it in the debugger. Shift F5. That's how you do that. So we have not handled that yet. We are not handling any of the Windows messages. We're not handling any of those things at all. Our window is still there. But I guess some of them, like minimize, maximize, are handled by, so you can still do those because they are handled by the def window proc and that sort of stuff. But close, we intercepted. Now, if you want to, if you really, really need to right now, you cannot wait till tomorrow and you need to handle those, what you can actually do is you can just get rid of them. You can let def window proc handle those. So if we just get rid of everything but our WM paint, it's gone, right? Well, in fact, I could just do this. Comment that out for now, right? If I actually just run that, now it will respond to WM close, right? Makes sense? Hopefully that's clear enough. But basically, there's a reason why you wouldn't want to do that. The reason that I didn't want to get into this, and so I really shouldn't get into it now, is that won't actually kill the application. It'll just close the window. So you'd still have to do one more thing if you really wanted your window to be working. What you'd have to do is get rid of these so that the def window proc handles it. And then inside WM destroy, you'd have to post quit message. And that's basically a call that posts. Remember, I was talking about that WM quit that gets posted out here. That will post that message, which will cause get message to return. But this is too much stuff to just flippantly throw at you. But that's it. I mean, that's the working program right there, if that makes any sense.
But we're going to do that tomorrow, and I'm going to explain it in a little more detail. So, if you're watching the stream right now and you're really antsy, that's what you'd have to do. But please don't, please hold that thought until tomorrow, because tomorrow is really when we'll be dealing with that. Is the for just a shortcut for have an infinite loop, or does the compiler just insert its own variable for condition? Yes, the for is the syntax for an infinite loop. It is the preferred syntax now for an infinite loop, and the reason for that is it used to be while one, and what would happen is if you change the warning level, and you know what, I'm going to see if I can actually just change the warning level for you. Let me see here. Where is the warning level? Warning level. Somebody tell me where the warning level is. Warning level, W all. So if I change the warning level to be more stringent, I will see if this compiler does it. Oh, Lord. Yes, well, thank you for all of that. Let me see if it actually warned. There it is. My Lord. This is all warnings in the Windows header files, ladies and gentlemen. Windows' own compiler can't even compile its own header files without warning. But anyway, conditional expression is not constant. This is what you will get. Conditional expression is not constant. And so the problem that you will have is you will get these warnings because you have put into a while loop something that can never change, and it thinks that's a problem. Now, I have no idea why it thinks that's a problem, because it's pretty clear if someone typed while one that they wanted to loop forever. I'm not sure what they could have meant. But for some reason, they decided to start warning about that. So for is the thing that will get rid of that. And now you will note that error no longer shows up. After all the Windows headers we get down here, and all it's got is the unreferenced formal parameters. There are these parameters here that we did not reference, and it's just warning us about those. So we're good to go. I'm going to turn off WAll for now. We may turn on some more warnings in the future. Probably not those, because we don't want to see the Windows headers ruin us all the time, but maybe we will even do that later, because there's a few tricks we can do to get around that. But point being, that is what the semicolon is. Let's see. Instead of printing them and close the timeout, can we handle it so we can close the window? Tomorrow night. Tomorrow night. Can you explain one more time the window handler and the messages infinite loop? Absolutely, I can. So here's what happens. We open a window. Windows creates that window. It returns control to us. We see if we got it. We got it. We enter an infinite loop where we ask Windows to give us the next message in our message queue, which it sticks into here. Right? This is basically a place where it gets written. And you can go look that up. It's an MSG, right? MSG. And you can see inside the MSG what is actually contained there. So we go in here and you can see it's got the window that the message pertains to. It's got that message code, the WM paint, the whatever. It's got the two parameters to the message, which we haven't looked at yet and we will look at tomorrow. It's got when it happened, like a timestamp, and it's got a point, which is basically usually where the mouse was. Yeah. The cursor position of screen pointer is where the mouse was. It's where the mouse was when the message occurred. Now that's meaningless for most messages because most messages don't pertain to the mouse, but legacy reasons that was included in a message, so there it is. It's going to take that sort of message that we got, going to stick the data in here, and then we're going to check to see whether it is whether it was able to get a new message for us or whether it had WM quit or an error or something. Assuming that it didn't, which means the return code will be greater than 0, we are going to ask Windows to basically translate that message in place for us. So Windows is going to go process the data in there to basically turn it into something slightly different. And it's basically just for processing keyboard messages, and we'll talk a little about that when we actually go to handle keyboard input. We'll come back to that and say what that does. But that's all that does is translate those keyboard messages. Then we're going to call dispatch message, and what dispatch message does is it takes the message and actually sends it to the main window callback. Now, we could call that window callback ourselves with the message, but there's reasons why we don't want to do that, because Windows wants to be the person doing the dispatching for a number of reasons. That's the way it expects the control flow to be, so it's best if you don't try to field the message yourself. Once we dispatch that message, we will just come back to the top of the loop and get the next message. So we are essentially sitting in an infinite loop, waiting on a queue, and Windows is stuffing those messages in the queue, and we're just pulling them off. We pull one off, we process it, we pull one off, we process it, we go to get one, and if there isn't one there, Windows will basically stall our process. That's what get message does. It will stall our process until there is a message. So it'll just wait. When there is a message, it'll give it back to us, we'll dispatch the message. So it's basically just waiting for messages and getting them. Now we will change this when we actually go to write our game's animation. We will change from using getMessage to using a thing called peekMessage, so we can just look to see if there's anything in the queue, and even if there's nothing in the queue, we will still do stuff, because we are running our game, and our game is always running, right? So getMessage is just temporary, so when I can show you stuff, it's the simpler way, but we will eventually turn into a real-time game loop where we're calling peekMessage, so we're gonna upgrade in some sense to peekMessage over time, but we're starting with getMessage because we don't need that flexibility just yet. If you want to see this in action, you can do it yourself. All you have to do is actually come in here and watch it happen in the debugger. Here we go. I jump in here. I create my window. You can see the window flash for a second on your machine. The Twitch stream probably optimizes that out. We are going to call getMessage, and we're going to receive a message. You can go look at the contents of that message. Type it into the watch window. There it is. This is the window that it's targeted to. Hey, we only have one window, so I bet that's the same window. And if you look, they are. Here's our window handle that came back from Create Window EX. Here's the window handle that Windows says this message is destined for. That's exactly what we'd expect. Here is the message right there. That's the message that's going to get dispatched, 49401. I don't know what message that is. Maybe it's WM Create. Oh, I can't actually see what the value of WM Create is. All right. Well, you know what? There's another way we can do that. Let's go ahead and look into the include directory. This is something that I was not going to talk about quite yet. But you know what? We can go ahead and do that. So we're going to go to Microsoft Visual Studio. As directory here, we are going to go into the VC directory, into the include directory, and I am going to search it for WM Create. Or at least I'm going to try to, oh, yeah. Yes, love this bug. This is an Emacs bug in later versions of Emacs. We'll also talk about this later when I actually have to do a grep on the actual stream. I should probably fix that in the Emacs file. In fact, I'm going to write to fix that in the Emacs file so you guys don't have to deal with it as well. There's an Emacs bug, basically. Fix, find, stir, Emacs. We'll take care of that for you. You don't need to worry about Emacs. Let me handle Emacs. We are going to search for WM Create, and we are going to find out where it actually is. Is it in here, or is there a platform? Do I have user 32? No, I don't. Okay, where is the platform SDK, ladies and gentlemen? Where is the platform SDK? Let's find out. Open documents. Can I actually get windows.h? Where is it? It's in Windows Kits. These things jump around so frequently, man. I don't even know. Windows Kits. 8.1, I guess. Where is it? 8.1 include. Include, and it is just in the main one. Yes, windows.h. There we go. Okay, I am now in the right directory. I will search for WM Create, and I expect to find it, although it's going to have to go through a ton of these include files here to find it. There it is. It has found it. I'm just searching the drive for it, and it is OX1, so that is not it. It is, what is the message that we actually received? It is C0F9. Let's see if we can find that one. C0F9. Grep C0F9. Is that anywhere? Let's see. Oh my lord. That doesn't look right at all to me. So I don't know what this message is. What is this actual message? I do not know. I do not know what that message is at all. Well, I suppose it could be defined in its 49401. 49401. I would like to find which message this actually is. But Windows sends a lot of messages that we won't understand, so it's not really a problem that it does. This will be handled by def window proc, but I don't know what that window actually is. Interesting. Well, unfortunately, I guess you can't actually see what what message that actually is. We'll have to look and see if maybe we can figure out what that message is later. What we can do here, though, is we can continue this, and then I'll keep pumping this till we find a message we actually can, that we actually expect to get. Okay, so translate message will operate on this message if there's something to do, but there wasn't to do. And then dispatch message, right? If I actually set a breakpoint up here in this, you will actually see that when I step over this to dispatch message, we end up in our window callback. So here's the call stack. You can see us. We called dispatch message, right, with the message. It called through user32dll twice. User32dll is the user interface portion of the code in Windows. It did whatever it's going to do to message dispatch, and then it got back to us when it was ready for us to field the message, right? Make sense? And so let's take a look at what that message actually was, 49401. We don't know that one, so we're just going to call def window proc, right, and come back out. We pop out, this is Windows code right here, assembly language. We don't know what it's doing. It's doing some Windows stuff, doing some more Windows stuff that we don't have the source code to. We returned out once, we returned out twice, and here we are back in our source code, right? Go through the loop again, get the next message out. Oh, and this is also awesome. So you may ask, actually, why we had to register this window class, right? Why do we have to register the window class at all to give it this callback when we are the people fielding the message loops? Well, it's because Windows message loops are all kinds of messed up. Even though it looks like we are handling the messages here by going translate message, dispatch message, Windows also reserves the right to basically just flat out call our window with some other out of bounds messages basically anytime it thinks that it needs to handle them. So this is where most of our Windows messages will be dispatched. But like you saw when that happened, right? I stepped over get message. Well, anytime we basically yield to the system, when we call into the system, it might call us back right there. And in fact, I can prove that to you. If you go here, you can see this is where we were. This is where I stepped. And it went through user32 DLL, it went through NTDLL, back through user32 DLL, called, and eventually called us back. So it wanted us to do something here that was right immediate. It didn't want to wait to go through the translate message. It had something it needed to do immediately. Message 127. What is message 127? That's 7F. Can we find that one, ladies and gentlemen? And I don't know if we can. 007F. We didn't have much luck before. Let's take a look. Get icon. There you go. It wanted to know what the icon was for our window. And it thought that was so important that it had to call outside of the dismiss messages. Ladies and gentlemen, there you go. What can I say? Windows. It makes very little sense. It aggravates you, but it is the platform you have to ship on. I'm going to go ahead and pop our stack back out here. In fact, I'm not even going to because, man, it's calling all sorts of stuff outside of our translate message loop. So I'm going to go out here, and I'm going to wait for it to actually get out of that get message. And here we are. So now we've pulled off, it's called us multiple times with messages we did not get to field this way. So it just flat out cold called us. And we're popped out here with another message for us to translate and dispatch. And so now I can actually, again, set it here, jump in, and you can see us fielding that message, right? So there you go. Okay. That's basically how it works. There's not that much to it. But basically all I can say is, yeah, I'm glad you asked that question because we got to see that in action. And I never really mentioned that fact in the mainstream, that the whole reason you have to register the window class and give it a window callback, instead of just handling it here and using your own callback or telling it what the callback is or something like that, is because every window that's created has to basically have a callback known all the time, because it basically has to be able to call you at any time. It can just flat out call you. It doesn't have to go through this. Because you could imagine if it were more sanely designed and every message actually went through this message queue instead of getting short-circuited like that, like it did, you could imagine not needing a dispatch because it would just say, here's a message and here's the window. You figure out how you want to handle that. And you wouldn't even need to define this callback because you would always be the person calling it. And that would be preferable in my opinion. But they did it this other way. So sometimes you're actually fielding messages in the queue like you expect, but other times you may call a Windows function. And it doesn't just have to be get message. It could be any function really. And it decides it needs to call your window back for something. It just does. That's just something it's going to do. And there's nothing you can do about it. So that's how that works. We are out of time. It is 9:36. We will have to pick up anything that didn't get answered today. So thank you very much, everyone, for joining us. There's a couple questions. Using output debo string A to print a string. How do you print a variable? When and how often will WM paint be sent? Can you show how to look at window messages WinSpy? These are things we will be doing. So just hold off till future strings, and we will show all of those things because they are all good questions and they are all good things to cover. So we will. Thank you very much, everyone, for joining us. We will be back here tomorrow at 8 p.m. PST for day 3 of coding, when we will actually draw in a very efficient way, or at least a much more efficient way, to our window so we can actually start putting game images up there which is what we want to do rather than having to use Windows calls to do stuff, because we want to write our own renderer and we need a way to get the output of our renderer into a window. And that's what we're going to do tomorrow. So thank you very much, everyone, for joining us. I hope you were able to follow along. It's a fast-paced thing, because you saw we only had one thing to do today, but I really had to speed through to get through it, and that's the way it's going to have to be. I appreciate everyone hanging with me. Thank you for asking questions. Thank you for trying this at home and asking questions. The people who asked, because they were saying they couldn't, they had the warnings about the skipping basic block. That's exactly what you should be doing. Trying this stuff on your own, seeing what works, exploring, reading that MSDN documentation, experimenting. That is how you will get good. I am giving you the backbone to sort of see how this is done. But to really build that understanding, you've got to try it yourself. You've got to practice. And that is the way that you will get good. So please keep on doing that. Thank you very much for joining us, and I will see you here tomorrow night.